Remember, you can only use the law of sines if you know an angle and its corresponding side. So what if I don't know an angle and its corresponding side? What if I know side, angle, side, and I want to solve the triangle? If we have side, angle, side, we have a different set of formulas for solving the triangle called the law of cosines. The way the law of cosines works is the side that you're looking for squared. So if you're given two sides, to find the third side squared is equal to the sum of the other two sides squared minus 2 times the other two sides times the cosine of the included angle, or the angle that corresponds with the side you're looking for. What if I don't know these two sides in this angle? What if I know sides C and A and angle B? Then I would be finding side B. So the side I'm looking for squared would equal the sum of the two given sides squared minus 2 times the two given sides times the cosine of the included angle, or the angle that corresponds with the side I'm looking for. Or if I'm given these two sides in this angle, I would be looking for angle or side C. So the side I'm looking for squared would equal the sum of the other two sides squared minus 2 times the other two sides times the cosine of the included angle, or the angle that corresponds with the side you're looking for. So let's do an example where we're going to use the law of cosines. Suppose you want to fence a triangular lot as shown below. If two sides measure 84 feet and 78 feet, and the angle between the two sides is 102 degrees, what is the length of the fence to the nearest foot? Now, let's first figure out what they're asking us to find. They're asking us to find the length of the fence. We're fencing the entire lot. So if the entire lot is that triangle, they're asking me to find the perimeter. But in order to find the perimeter, I have to know the measure of all three sides, which I don't. Now, if it helps you, you can call this triangle ABC, and then you can say, well, I'm finding side B. It helps you with what formula you're using. I'd like you not to try to remember the law of cosines that way. What I want you to do is I want you to remember the way the law of cosines works is the side you're looking for squared is equal to the sum of the squares of the other two sides minus 2 times the other two sides times the cosine of the included angle. Now, remember that the way this formula works is you're looking for the side squared. That means that at the very end of the problem, you need to remember to square root it. Also remember to make sure that your calculator is in degree mode and not in radian mode, because then you'll get some very off answers. Now, the reason you kind of remember to square root it at the end is because if you forget to square root it, you're going to find out that x squared is about 15,864.5. Well, that really doesn't make sense since the other two sides are 84 and 78. So you need something that's a little more consistent with those two sides. So when you square root it, you're going to find out that the third side's about 126. It's 125.95, so I made 126. But that's not the answer to our question, because our question was what's the length of the fence to the nearest foot? So last but not least, we're going to add 126 plus 84 plus 78, which is 288 feet of fencing needed for this triangular lot. The nice thing about the law of cosines is, unlike the law of sines, it doesn't have an ambiguous case. So the only time you have to worry about the ambiguous case is when you're dealing with the law of sines. So in example 2, we're going to solve each triangle. Remember, solving the triangle means finding all three sides and all three angles. I want you to set up a chart like this, and I want you to start by filling out your givens. The other thing you can do is, if it helps, draw the triangle, because for some people, drawing the triangle helps them see that they were given side, angle, side, and that the missing, so they have to first start by finding the missing side, which is side A. So let's do that. The side I'm looking for squared is the sum of the squares of the other two sides minus 2 times the other two sides times the cosine of the included angle. Don't forget to square root it at the end. And you get about 8.96. I'm just going to round that to 9 because if you round it to the nearest tenths place, it rounds to 9 either way. So once you've done the law of sine or the law of cosines, you don't have to use it again because now you'll see that I know an angle and its corresponding side. Once you know an angle and its corresponding side, you can now revert to the law of sines, but there's a caveat. And that is that you have to find one of those angles over the other. So let's talk about why the law of cosines doesn't have an ambiguous case, and then go back to this problem to determine which angle we're going to find. Remember, all students take calculus. This was a nice little way of remembering in which quadrants each trig function will be positive or negative. All the trig functions are positive in 2 of the quadrants and negative in 2 of the quadrants. So when we were dealing with the law of sines, sines were positive in quadrants 1 and 2. Problem was, when you found an angle using the law of sines, it only ever gave you an angle in quadrant 1, so you had to find the angle in quadrant 2 by using the reference angle. The only other angle that inverse sines will give you is angles in quadrant 4, if the angles are negative or between 270 and 360. But triangles, you can't have an angle that's between 270 and 360. We're sort of bound by 2 different types of triangles. Well, 3, I guess. You have an acute triangle, an obtuse triangle, and a right triangle. And in an obtuse triangle, only one of the angles is obtuse, and the other 2 are acute. When you do an inverse cosine, so when I talk about how to restructure the equations that we just talked about to solve for an angle rather than a side, we talked about how inverse cosines will always give you angles in quadrant 1 and 2. So you don't have to worry about the ambiguous case, because if it's an acute angle, it'll give you an acute answer. If it's an obtuse angle, it'll give you an obtuse angle. Problem is, the law of sines doesn't do that when you find an angle. The law of sines will always give you the acute angle. So let's talk about the obtuse case. In the obtuse triangle case, the largest angle may be obtuse, but the other 2 are acute. Or the triangle has 3 acute angles. So now coming back to this problem, you need to find the smaller of the 2 angles first using the law of sines. The reason is because I don't know if the biggest angle is acute or obtuse. I know that the 2 smaller angles have to be acute. Otherwise, it doesn't make a triangle. So we're going to now use the law of sines to find angle B. So the rule is, once you've used the law of cosines one time, you don't have to use it again. You can use the law of sines now to find the next missing angle. But in order to do it, find the smaller of the remaining angles, because it has to be acute. And that's what you're going to get on the calculator anyway. All right, so we set up our proportion. We're going to cross multiply. I get 9 times the sine of B is equal to 12 times the sine of 39.4. We're going to divide by 9. And that makes this go away. And then we're going to inverse sine that answer. Remember, when you're finding an angle, that's the only time you're going to use an inverse sine. And you're going to find out that angle B is about 57.8 degrees. All right, let's come back up. And now that you have 2 of the angles, you can just subtract them from 180 to find the third angle. And the third angle is going to be 82.8. And there's the solution to your triangle. Not only can we use the law of cosines to find a missing side, but we can also use the law of cosines to find a missing angle. So what if instead of being given side, angle, side, I'm given side, side, side? If I don't know any of the three angles in the triangle, I can't use the law of sines. So I have to use the law of cosines. But in order to do that, we're going to have to derive my equation. So we're going to do this for one of the equations. I want to solve this equation for cosine A. In order to do that, I'm going to use just my general run-of-the-mill Algebra 1 policies in order to convert it. When you solve an Algebra 1 equation, the first thing you always look for is something you can add or subtract. So I can subtract the b squared and the c squared. No, you cannot get rid of the negative 2bc, and the reason is because it's being multiplied by the cosine of A. Because after you move anything that can be added or subtracted, the next step is to look for things that you can multiply or divide. So because it's being multiplied by the cosine of A, I can divide it. And this is the equation that I can use to find angle A by using the law of cosines. So what's going to happen is you're going to evaluate this fraction, and then you're going to do the inverse cosine of it. However, I'm going to show you in a moment the best way to plug it into your calculator so you don't make a mistake. If it makes you feel better, I'll tell you what the other two equations are. Cosine of b is b squared minus a squared minus c squared over negative 2ac. And cosine of c is c squared minus a squared minus b squared over negative 2ab. So now let's go do part B of example 2. So I'm given side, side, side. The first thing I'm going to do is I'm going to set up my chart and put in my givens. Now, because it doesn't matter which angle you find, because the law of cosines doesn't have an ambiguous case, I will make a recommendation. Because the law of cosines will give you an obtuse angle if the angle's obtuse, or an acute angle if the angle's acute, I would recommend finding the largest angle using the law of cosines. That way, you don't have to worry when you do the law of sines because the other two angles have to be acute. So, if I'm going to find angle B, the cosine of B is b squared minus a squared minus c squared all over negative 2 times a times c. Now, in order to plug this in my calculator so it doesn't mess up, I'm going to type it in like this. So, parentheses, put in 24.3 squared, oops, not plus, minus 19 squared minus 21.8 squared, and then close the parentheses on the numerator. Divide by parentheses, and this is where the denominator is a little bit different from what I wrote. I want you to type in negative 2 times 19 times 21.8. So don't use parentheses around those numbers. I know I wrote it that way in the problem, but don't do it in your calculator. Type it in like this. Then when you get your decimal, you're going to inverse cosine it. And you should find angle B is about 72.7. Now, if you want to use the law of cosines to find your second angle, you can. There's no rule that says you can't use the law of cosines more than once. Most people prefer to go use the law of sines because they're more comfortable with it. But if you'd like to use the law of cosines to find angle A or C, go ahead. I'm going to go use the law of sines just because. So now that I know a side and its corresponding angle, I'm going to do the sine of 72.7 over 24.3 is equal to the sine of A over 19. So we're going to cross multiply, and I get 24.3 sine of A is equal to 19 sine of 72.7. I'm going to divide by 24.3. And then I'm going to inverse sine that. and it's going to give me about 48.3. Now, once you've got two of the angles, remember, you don't have to use the law of sines or cosines to find the third angle. You just have to subtract them from 180 because you know the angles inside a triangle add up to 180. And we're going to find out that the remaining angle is 59. And there's the solution to the triangle. When we first talked about the law of sines, we talked about a formula for finding the area of triangles using sine. And it's a little bit different from the one you did in geometry, because in geometry, when you had a triangle ABC, in order to find the area, you had to know the base and the height was normally an altitude inside the triangle. If it was an obtuse triangle, the height or altitude was outside the triangle. And then you would use 1/2 base times height. Well, we found out that if you had side angle side, that you could find the area of the formula by doing 1/2 of the two sides given, which are not those two sides, that would be B and C, times the sine of the included angle. And the reason the book used K instead of A is because they didn't want you to confuse it with angle A. So if only I knew side angle side, I could find the area of this triangle ABC. The thing is that I actually know 3 sides and not an angle. So I'm going to have to find an angle. So now let's go back and do this again. Triangle ABC, whose sides are 24, 52, and 39. Well, I know all 3 sides. I need to know one angle, and that's all I need to know. What angle should I find? Makes no difference. How about we find angle A, just because it's angle A? We're going to have to use the law of cosines. So the cosine of A is going to be A squared minus B squared minus C squared divided by -2 BC. I'm going to put this in my calculator. I'm going to repeat this again. The way you're going to put it in your calculator is parentheses. 24 squared minus 52 squared minus 39 squared, divide by parentheses, -2 times 52 times 39, and then you'll inverse cosine that answer. And you're going to find out that angle A is about 25.9 degrees. Now that I have side angle side, I can find the area by doing 1/2 of the 2 given sides times the sine of the included angle, which is about 443 square units. Now, it didn't matter what angle I found. I could have found angle B and used sides A and C, or I could have found angle C and used sides A and B. I would have gotten the same area at the end. However, there's another formula for finding area if you're given 3 sides of a triangle. It's called Hero's or Heron's formula. Depends on what textbook you're looking at. And the way it works is for triangle ABC, the area can be found by doing the square root of S minus A, S minus B, S minus C, where S is found by taking half the perimeter. So let's try this formula out. Let's find the area of triangle ABC, and then let's round the answer to the nearest tenth. So first, we're going to find half the perimeter. That's called S. So we're going to add the 3 sides and divide it by 2. And I'm going to get 72. To find the area, you're going to do the square root of 72, and then you're going to do 72 minus side A, 72 minus side B, and 72 minus side C. Whatever value you get for S should always be smaller than the 3 sides. If it's not, you'll end up with a negative under a radical, and you can't take the square root of a negative. If you have a calculator with a newer operating system, you can actually just plug this into your calculator verbatim and hit enter. However, if you have an older calculator like a TI-83, I would recommend evaluating the part that's under the square root sign and then square rooting it. Either way, you should get about 978.6 square units. And that is the law of cosines.